Okay, this introduction states that the special Two Turtles and a Sloth concert was amazing. The friends enjoyed it so much they wanted to order specialty t-shirts with their names on the back to remember the great night they had. The shirts were $18 plus an additional $5 for their names, and they wanted to buy one for each of the 7 friends that went. Question 1 states, how would you find out the total price of the shirts? Okay, so let's go ahead and look at this. We have to pay $18 plus $5 for every one of the 7. So that means that I'm going to put parentheses around this, and I'm going to multiply that by 7. So 7 times the 18, they're going to have to pay $126 for the shirts, plus 7 times 5, $35 if they want to put the names on the back. So all together, that's going to be $161. Okay, another way that we could have done that, well, let's try this. Let's see, 18 plus 5 is 23. Or we can say that it costs $23 for each one of the 7. And it's 7. Well, does 23 times 7 equal 161? Yes, it does. So either way that we can do that, we can combine this, or we can say it's going to be 126 for the shirts plus the 35 for the names on the back. Again, either way, it's going to cost us $161. The next question says, how would you write an algebraic expression representing the total price of the t-shirts if you did not know how many people were purchasing them? Well, let's look at the little expression that we created up here. The 7 represents the people. If we don't know how many people are purchasing them, why don't we say P equals people purchasing? So still have to pay the $18 for the shirt, still the $5 for the name on the back. The only difference is we don't know how many people. All right, well, let's look at what we did up here. We took 18 times 7 to get the 126. So here we're going to take our 18 times P. And remember, we always like to keep the variable second. Then we had to say, well, it cost that $5 extra for the name on the back, so it's going to be plus that $5 extra per person. Okay, here's the question. Can we combine those two, or do we have to leave it like that? Well, look at what we did up here. We took 18 plus 5, and we knew it was $23 per person. So it looks like we can go ahead and combine these and say that it's going to be $23 per person. Okay, this is a good example of why we can combine these. It's called combining like terms because they both have that variable P attached. If this dealt with something else, that it was $5 just per all the purchase together, we wouldn't be able to add that together. But since we did have the same variable attached, we can go ahead and combine those like terms. Okay, looking at this next one, it says they were also thinking of ordering specialty backpacks with their names on it. They didn't know the price of the backpack, but it was still an additional $5 to get their names printed on it. Question 3, how can we use the same concepts from question 1 to write an algebraic expression to represent the total cost of the backpacks if all 7 purchase them? So again, let's look at question 1. That 18 dealt with how much each one of the shirts cost. Well, down here, we don't know how much that backpack costs. So here, we're going to say that B equals cost of backpack. Okay, that's the piece that we don't know. So let's go ahead and fill in all the blanks. We know that there's 7 people that are going to purchase them. The variable now is going to be right here. We do know it's still that $5 to get your name printed on it. Okay, again, writing an algebraic expression. So what can we do with all of this? Well, we know it's going to be the cost of the backpack times the 7 people. So it's going to be 7 times that amount plus the $35 for the names. So it doesn't matter, again, how much that backpack costs. We still know that we're going to have to pay $35 for the names on the back. What I just did was called distribute. I took that 7 and I multiplied it by both of the pieces inside. 7 times B, which is going to be the cost of the backpack, plus the $35 for the name on the back. So here's the question. Up here, we combined these and had the 23p. Down here, can we do that? Well, the answer is no. Look at this. It's not like terms. That $35 has nothing to do with the cost of the backpack. It has to do with the names printed on the back. So these are not like terms, which means this then is going to be my final answer. Okay, one more. It says they find out the backpacks are on sale for $19 if they print the same name on each one. They want to purchase 7 backpacks with Slow and Slothy 7 printed on them. That's going to be the name of their little gang. They need to quickly determine how much it's going to cost since they only have $135 left. Well, many people can't just take 19 times 7 quickly in their head. So what I'm going to do is show you a really quick way to figure this out. We like numbers that end with 0 because we can easily figure out what they are. Well, look at 19. What number is that close to that ends in 0? 20. Okay, so 19 is very close to 20, but it's not quite 20. It's one less than that. So I'm going to rewrite 19 as 20 minus 1. Algebra is a lot of taking a number and changing it many different ways. 19 has many different names to it. It could be 18 plus 1. It could be 20 minus 1. Right now, we're going to call it 20 minus 1. Well, we know that that's 19. We know that we're going to multiply that by 7. So I'm going to take this and I'm going to multiply it by 7. And now I don't need a calculator. Now I can quickly see that this is $140, but I have to actually subtract 7 of those because I rounded that 20 up, I rounded that 19 up to 20. So real quick, I see it's around 140, but I have to take away 7 of those dollars because of that rounding. So now I can see that it's going to cost them $133. Without a calculator, I could have quickly done that in my head. Okay, so let's make sure that I'm not circling the wrong thing. It says, what is the quick way to use the concepts from above? Well, look what I did. I distributed that 7 through. So I could quickly do it in my brain. Last question, do they have enough? Yes. Okay, so again, this section is going to be about that distributive property, taking whatever is outside that parenthesis and multiplying it by all of the expressions inside. All of the terms inside. It's also going to be talking about combining like terms, simplifying, not leaving an answer as 18p plus 5p, simplifying that down to 23p. But then also realizing that sometimes you can't do that. Sometimes we don't have those like terms, so we have to leave it as an expression. Go ahead and get out your notes and vocab for this section. Okay, the objective of this section is to add, subtract, factor, multiply, and expand algebraic expressions with rational coefficients. And we will talk about the vocabulary word coefficients in just a little bit. I did put what the book had with the distributive property here. If you're more of a visual person, you can look at using kind of the algebra tiles to understand that. I also put, a lot of times they like to use these variables. And students should get used to this, understanding that if this is confusing, put some numbers in there. So instead of A, put 2. Instead of B, put 3. Instead of C, put 4, and understand what that means. They like to use these symbols because you can plug anything in for those variables in order for it to make sense. And they do give some pretty good examples there. Again, I'm not going to go over that because we already did in the introduction. Looking at example 1, we're talking about sports. It says a group of 7 adults and 6 children are going to a University of South Florida Bulls baseball game. Use the distributive property to write and evaluate an expression for the total ticket cost. So here we go. We're going to write an expression and evaluate, understanding that evaluate means actually solving the problem. So let's look at that. 7 adults and 6 children. Well, it looks like an adult costs $5, a child costs $3, a group of 10 or more for a single game costs $2, and then seniors 65 and over are $3. It's very important to actually go through the whole table and answer that, because right away we want to say, oh, well, we're dealing with 5 and 3. But look at this. Groups of 10 or more are $2. It looks like we have 13 people going. So it's going to cost each one of them $2. So we have 7 adults plus 6 children. And we know each one of those is going to have to pay $2 to get in. Again, that distributive property, what I'm doing is I'm distributing that 2 through the parentheses. I'm multiplying that 2 by every piece in the parentheses. So it's going to cost $14 for the adults to go. It's going to cost $12 for the children to go, which means it's going to be a grand total of $26 for them to go to this baseball game. The question is, well, couldn't I just multiply that 7 and 6 together real quick and say 13 times 2 is 26? Sure, that would be fine. But understanding that distributive means we're distributing that 2 through the parentheses. Go ahead and try guided practice 1. Okay, this is a good problem because, again, you really have to read it a couple times to understand it. We have a group of 3 adults that are going, so that's going to cost them $5. So 3 adults times that $5. We have an 11-year-old and 2 children under 10 years old, which kind of sounds like that's 2 categories. But looking at our prices up here, it's children 12 and under. So that's actually 3 people that fit that category of $3 each. I like this problem again because it says that we're supposed to write an expression, and a lot of times students think that expression means we have a variable in there. Well, remember that expressions deal with variables and numerical values, so we don't need to always have a variable in there. Here we know exactly what we need to know. So 3 times 5 is our 15 for our adults, $9 for our children, which is a grand total of $24. All right, looking at example 2, this is that mental math where we want to quickly get an answer without having to grab a calculator. I really do like these because it's a way to get kids to kind of think outside of the box, understanding that numbers definitely do have different names. So let's look at this. We're supposed to rewrite 7 times 49 in order to quickly get the answer, and then we're supposed to evaluate. Again, we like nice round numbers because we can multiply by zeros much faster than we can by nines. So let's look at the number that we can change. It looks like 49 is really close to a nice round number of 50. So I want to rewrite 49 as 50 minus 1. Okay, I know that I'm going to multiply my 50 minus 1 by 7. Okay, much quicker to do this because 7 times 50 is 350. I have to subtract 7 of those, which means I end up with 343. Okay, a little bit faster than grabbing that calculator or trying to write it out by hand. All right, go ahead and look at the guided practice. And again, our goal is to rewrite these numbers to figure out a nice quick way that we can get the answer. And evaluate means find the numerical value. Of course, the problems are always trickier than the example. But looking at these, actually, all we did was rewrote the 304 to 300 plus 4. It wasn't the 15 that we could change. You could have changed it to 20 minus 5, and that would have worked. Some pretty big numbers, but you should have ended up with 4560. 2b is kind of a nice one because, again, 2 1/2. Let's break that up to 2 plus that 1/2. So we have 88, and we're adding 22 to that. Okay. 210, again, you could have changed the 210, you could have changed the 5, but looking at this, I have 200 plus 10 to break that up a little bit. 2D is probably the trickiest one. You could have gone a couple ways with it. Still dealing with some big numbers, but at least we can break it down a little bit instead of having to multiply 2-digit numbers. So I took 50 plus 2 and multiplied it by 17. Again, this is just a good way to get kids to think that there's not only one way to write the number 304. Okay, moving on. Now actually looking at expressions with those variables in it. So what we're supposed to do is we're supposed to rewrite each expression using that distributive property, and then we're supposed to simplify. Well, we're getting pretty used to understanding that distributive means that we're going to take that 7 and we're going to multiply it by each of the pieces inside. So I'm going to start with 7 times 3w. I'm going to take my 7 times 3, which means 21, times the w, whatever that is. So $21 times however many watermelons I'm buying. It's a pretty expensive watermelon, but it'd be good. And then the 7 times that negative 5. And this is the part where students get a little bit confused because that looks like a subtraction sign, but remember that subtraction signs are actually adding the opposite. So this is actually saying 7 times a negative 5, which is a negative 35. Okay, when it does say simplify, don't have students say plus the negative 35. Rewrite it as 21 minus 35. And that is our final answer. Okay, this one's a little bit trickier because the 4 is on this side. Does that matter? It actually doesn't. It just means that my arrows are going to be going the opposite way. Some students might want to rewrite that and have the 4 out front. That would be totally fine. I'm going to actually start with the 6v squared, and I'm going to go from there. So I have a 4 times a 6, which gives me a 24v squared. I have a 4 times a v, which sounds kind of weird. Anytime that there's just a variable out there, I always like to put a 1 out there because this is a 4 times 1, which is a positive 4 times a v. Remember that subtraction sign. Get used to seeing that as a negative. So I'm going to say 4 times a negative 3, which is a negative 12. Okay, question here. Can I add any of those together? Well, notice up here when we talked about that, these are not like terms, which we will get into more a little bit later. So this is going to be my final answer. Here's another tricky thing. When we just have this little subtraction sign out there, which it kind of looks like, that's actually a negative sign. So anytime that I see something that looks like it's missing a piece, I understand that that's technically saying negative 1. So I like to put a 1 there to keep myself focused on what I'm actually multiplying by. So this is saying a negative 1 times a positive 2, which is giving me a negative 2. This piece right here is saying a negative 1 times a negative 5q. Well, negative times a negative is a positive 5q. So really focus on when you're multiplying these through, state in your head, what am I actually multiplying? I'm multiplying a negative 1 times a negative 5q, not a subtract 5q, but a negative 5q. And again, one has a q, one doesn't, so I'm going to have to say that's my final answer. Okay, go ahead and go through guided practice 3. Again, trying to say it in your head, what am I multiplying together? Okay, check your answers to mine. Noticing that I always like to use those arrows to help me stay focused. 3b, on this one it actually has 3 variables. Question is, can we combine them? No, remember that they're different variables. So this could be talking about rain jackets, this could be talking about rain gauges, and this could be talking about tents. So if they are not the same variable, you cannot combine them. Notice 3c, there was tons of negatives in the problem, but look at what happens afterwards, because saying in my head, I had a negative 4 times a negative 8, which turns positive. I had a negative 4 times a negative 3, which turned positive. So I see sometimes that kids like to write this as 32 and then 12m with nothing in between. And that's why, again, I like to say it in my head that this is a positive 12m. I'm actually adding them together. So make sure that they put that addition sign in between. All right, moving on. This is a little bit out of turn, I think, but just kind of reviewing what we have talked about. We talked about like terms, understanding that they contain the same variables, with corresponding variables that have the same power. So earlier we had a v squared and we had a v, and we couldn't combine those because they're not like terms. One is almost double the power than the other one. Noticing this one, we have the same variable and we have the same power, so we could actually combine those two. Notice again, these two do not have the same power, so they are considered unlike terms. We talked about simplest form in the introduction, where instead of leaving the 4k plus 8k, go ahead and combine those. We want to do as least amount of steps as possible, and we can combine them because we do have the same terms there. That word that we showed up in the objective was coefficient. What a coefficient is a coefficient of a term is a numerical factor. So their example is 6ab. that numerical factor is a 6. Sometimes we have something weird like this where we have an x squared over 3, understanding that there's a little ghost 1 hanging out here. So that's actually 1/3. And we're going to focus on that sometime later in some other sections. So up here, looking at coefficients, 5, the coefficient of 2. Okay, this is weird because when we look at that a squared, there's nothing out there. A coefficient has to be a number. So don't let students say that the coefficient of this is a squared. The coefficient is actually 1. And that's why I really do like to write that in there. So especially when we're multiplying, we understand what we're multiplying by. So some new vocab that we have to kind of keep in mind. All right, with that, let's go ahead and combine some like terms. So looking at A, we're supposed to simplify this. And I think we should already understand how to do this. Again, we have $17 for this umbrella plus 25 extra dollars to put some gold sparklies on it. So altogether, that umbrella is going to cost us, or each umbrella is going to be $40 per umbrella. We can combine those because, again, we have the same variable, we have the same power. Okay, looking at B. We have the same variable, each one of them has a t in it, but again, it has to pass that power test. This one is t squared, so we can't combine him with anything. That doesn't mean we leave him out. He is still part of the expression, but we can't combine him with anything. These two have that variable t, so let's go ahead and combine them. Question is, how do we do that with just this weird minus t thing? Again, understanding that is subtracting 1 t. We have 3 t's. We are subtracting one of them, so we have a positive 2t left over. Again, say that positive so we understand that we are actually adding that on to the problem. All right, go ahead and try those guided practice and then play the video and check with my answers. Okay, here are your answers. 4B is kind of a tricky one because looking at that, we do have two like variables, but they don't have the same power. They said nothing about the coefficients being the same. Remember, that's that fancy word. The 13 is a coefficient. So we can't combine those because they don't have the same variable. So 4B, simplified. Can't do much with that. 4C is kind of tricky because we have 2y and we're subtracting 8. Well, we understand with integers, 2 minus 8 is a negative 6. So when you wrote that, hopefully you said a negative 6y. 4D you might have written differently because it's in a different order. And again, we're going to go over this later, but the rule with expressions a lot of times is they like to have the highest power first. So that's why I put that a squared first, and then the a, and then the constant term because it does not have a variable. Okay, so a couple things to review with this. Remember that that negative 6 is a coefficient, that 5 is a coefficient. Remember, a term that has no variable attached to it is called a constant term. All right, moving on. Here's one where we have to write and simplify expressions. A couple words in here that we have to kind of get used to. It says that we're supposed to use the expression twice the difference of 3x and y increased by 5 times the sum of x and 2y. All right, that's a lot of different words in there. One thing that we have to see, words like the difference of, the sum of. Anytime you see those words, that means that we have to put a parenthesis around what they're talking about. Okay, so a lot of times this is what I like to do. Twice the difference of, that means that we are taking 2 and we are multiplying it by something. And means I'm adding. So what I'm doing is I'm basically kind of translating this up here in the actual sentence. Okay, twice, whoops, the difference of, ooh, that was tricky because that's actually difference. Difference means we are subtracting, sorry. Increased means we're adding by 5 times, again, the sum of x and y. So anytime, again, you see that sum of or that difference of, we understand that we're actually putting a big parenthesis around that. And now I can actually add because sum means addition. So a lot of crazy stuff going on, but this is a great way to start this problem. Go ahead and look at that problem and translate it up there, looking for those clue words. Now I'm going to go ahead and actually write this. So twice, I know that I'm taking 2 and I'm multiplying it by this. I put that dot in there to remind myself it's multiplication, but I don't really need it. I'm just going to put a parenthesis there, 3x. I know that that's a difference of, so I'm subtracting 3x and y. I'm adding 5 times that sum. So again, that dot just reminded me, but I'm not even going to put it in there. I'm just going to put a parenthesis right beside it and understand I'm multiplying by x and 2y. And there we go. So there's our algebraic expression. We translated it from words into algebra. Now we get to simplify the expression. So I'm going to go ahead and rewrite this down here. Again, simplify means that we don't have any parentheses in our problem. So looks like we actually have 2 different parentheses that we're going to have to distribute through. So the very first thing that I like to do is, again, stay focused on this. So here's a question. Do I keep multiplying that 2 through? The answer is no. Once I hit the end of that parenthesis, that's kind of my stop sign. I have to stop multiplying that 2. Here, I'm multiplying that 5 through. So I'm going to put arrows on that 5 and focus there. So I understand that I have a 2 and a 3x, which gives me 6x. 2 times a negative 1y gives me a negative 2y. So parentheses are gone there. I have a positive 5 times an x, so I get a positive 5x. I have a positive 5 and a positive 2y, so I have a positive 10y. All right, it does say simplify the expression, and remember the rule with simplifying is that we have the least amount of terms as possible. So the next thing that I do is I'm going to look through and see if I have any like terms. So here's an x here, here's an x here. So I'm going to put a line underneath these 2 and understand that I'm going to combine those 2. I'm going to look at this y. Here's a y and here's a y. So I'm going to put 2 lines under here to keep myself focused. As many visuals as possible to help yourself understand what you're doing does really help. So 6x and 5x, I have 11x's. Negative 2y and a positive 10y, I have a positive 8y. That was a pretty intense problem. So again, as many little clues to help you out with the little subtle ones in here, okay, any kind of lines really does help. So final answer, we can't combine those 2 because x's and y's are like apples and oranges. All right, looks like we have one more problem for you to do and then we're done with this. So go ahead and try that guided practice. Okay, looking what I did up here to help translate, again, understanding that that difference of is that clue word, that 5 has to be multiplied by both of those pieces, so I have to put that parentheses around it. And now I'm multiplying, that difference means I'm subtracting those 2 pieces. Here's a quick little different one that it was q squared, so I did put that up there to help me remember that. Okay, plus is a nice word. 8 times, there's that sum of, so I know that that 8 has to multiply by both of those pieces. So rewriting that as an algebraic expression should look like that. Now the fun begins that we have to simplify. Put those parentheses in there to help me understand. I could have put that 1 in front of that r to realize that this is 5q squared minus 5r. And then I multiplied that 8 through here. This is a little bit tricky because looking for like terms, we do have 2 variables q, but it doesn't pass the test to combine them because one has a power of 2, one has a power of 1. Okay, looking at those r's, it does pass the test. We have same variables, same power, so I started with the 5q squared. I did put the 24q right beside it because it's nice to keep the same variables together. And then I combined those, again, realizing this is a negative 5r, adding that 16r together to give us an 11r. A lot of different concepts here, but just remember that there's a lot of tests it has to pass in order to combine those like terms. Understanding when they say distribute, that says taking whatever is outside that parenthesis and multiplying it all the way through. I think you're ready for the assignment for this section.